My name is Bradley Jones. I'm the Senior Designer at the Experience Center in Irving, Texas. Today, I'm going to present to you an introduction into the world of agricultural packaging. I will introduce the basics of produce packaging, give an overview of common design features, and demonstrate how we can make small changes that will result in large improvements on performance. At the end of the presentation, I will conclude with an explanation of wax-coated paper and an explanation on why the water-based coating that Smurfit Kappa uses is a more environmentally conscious alternative. We will start the presentation with an introduction to agricultural packaging. The first topic to master when discussing any type of packaging is the purpose of the package. In the produce and agriculture market, there are four main functions of the package: protecting the product from damage, maintaining freshness of the product, surviving the supply chain, and displaying the product on store shelves. Product protection is sometimes achieved with the use of partitions, dividers, or inner trays. Fruits and vegetables that are more sensitive to bruising may need these dividers, whereas more robust produce may just be placed in the shipper as is. Maintaining freshness can be achieved with a variety of design choices. Every food has a specific set of requirements, from humidity and moisture to temperature and light exposure. There are several resources available to help customers determine the right package for every product. Stacking strength is another important metric when packaging produce. Many pallets can become very heavy when fully stocked with product, so it is crucial to pair the right structural design with the most optimal board grade. Ultimately, if the package does not survive the supply chain, the product will not make it to store shelves. We have developed an innovative tool that lets our engineers find the right board grade for every package. By inputting information on how the product is palletized and shipped, our program will give us a calculation on which board grade will perform the best for any given scenario. The final purpose of produce packaging is displaying on store shelves. Produce can either be distributed to stores in shippers and then unpacked onto shelves, or the shipper itself can be placed in the shopping area. In the case of the latter, the packaging needs to serve the dual function of displaying visually pleasing graphics while also displaying the product. Clever designs and graphics can aid in the selling of produce by attracting customers. After getting familiar with the main functions of the package, the next step is to understand the design options available for each product and which designs are common in the market. Shown here is an array of different produce packaging solutions. Each design fits the needs of the type of product it contains. There are many design elements to consider when designing agricultural packaging, and these examples highlight a few of those features. Trays with built-in dividers can be ideal for packaging multiple types of produce. For example, strawberries, blueberries, and raspberries can be displayed in the same tray. The built-in dividers separate the produce in the tray, eliminating the need for three separate packages. Standard RSCs are great for stacking strength, and they're easy to produce and assemble, but they may not be ideal for your product if your packaging requires high levels of airflow. Although they are very common in many other industries, their enclosed design and need for tape makes them a less than ideal solution for most types of produce. Another important variable to consider when designing produce packaging is whether or not your customer has a case or tray erector, or if they will be assembling the packaging by hand. Ultimately, this may determine the design you end up using. Having trays that are manually assembled can eliminate the need for costly machinery, but if the customer has a case or tray erector, they will be able to have much faster turnaround for making boxes. Each customer has different requirements and capabilities, so it is important to understand their limitations before providing a solution. Here are 5 common examples of trays that are currently in use in the market for different types of produce. These 5 examples show a range of design features that achieve different results. You will notice that most solutions we have here incorporate several design elements to achieve the complex demands of the product. The first example we're going to look at is an orange tray. This tray features rollovers on all 4 sides. These rollovers create more rigidity along the long edges of this tray. You can see this tray also has column-style rollovers on the 4 corners. These are required because the open sides don't provide very much stacking strength. So all of the stacking strength this tray encounters is focused on the 4 corners. The tray also has stacking tabs, which will lock into the tray above it, and holes for the tray below it. This will make for a more stable pallet configuration. The next example we have is a mixed fruit tray. This is a one-piece design with built-in dividers, you can see here. The tray is ideal for mixing smaller produce, like berries, for example, and also has the added benefit of being easy to assemble. No glue or tape allows this tray to be put together very quickly and easily. Our third example is a tray built for mangoes. This tray has several common design features found in produce packaging. Similar to the first example we looked at, this tray features stacking tabs that protrude over the top of the carton. This will help in stability when these trays are palletized. Very often, we find that a well-designed individual tray can create a more stable pallet stack. This tray also has built-in handles that allow for easier manual transport. This will be much easier for workers to carry when handling the product. The lowered sidewalls here provide very good visibility in the store, while the foldovers on the ends create for a more stable tray. The next design we have here is a box for avocados. This box provides excellent product protection because of its fully enclosed sidewalls. You can see that this design features stacking tabs on the top, and these stacking tabs have a very unique dual function of being locking tabs that hold the top flaps down. And all you have to do is close up the top of the box here, and these stacking tabs that lock the flaps will also double as tabs to lock the box into the one above it. This will create a very stable pallet layout as well. The final example we have here is a tray intended for garlic. This tray is very similar to a standard 2-sided rollover, but this one has extended flaps on the 4 corners. These extended flaps will prevent the tray from falling into the tray below it and have the added benefit of adding to the stacking strength of this tray. Because this tray has full sight sidewalls to keep the garlic in place during transport, air holes needed to be added throughout the tray to facilitate airflow. These 5 examples show that each product has specific needs that can be reached by smart design. By knowing the needs of the product, we can develop solutions. The variety of design elements shown here are just a few examples that we see in the market. And knowing when and how to use these design elements is a crucial step in providing the optimal packaging solution for the customer. To recap the design elements we discussed, open-top trays are ideal for loading product in the package and displaying product in stores. Column support in the 4 corners may need to be added when using open-top trays. This increases stacking strength and prevents trays from collapsing into the tray below it. Built-in dividers can be used to separate several types of produce in a single tray or provide added protection between produce that is prone to bruising or damaging. Stacking tabs can be ideal for keeping packages aligned on the pallet and increasing the stability of the stack. Air holes are used for increasing airflow, which can be needed to keep the product fresh for as long as possible. Edge rollovers reduce bulging sidewalls of trays. This can be needed for trays that have long sides but are not very tall. And handles allow for easier manual handling of trays and boxes, and they can also double as added airflow. There are two more important design elements of produce packaging to consider that are closely related to design. The first is the fluting that is used for the packaging. Many produce trays and boxes need to withstand a great deal of compression due to the heavy product and high pallet stacking. The weight of the product, coupled with the fact that most produce packaging encounters levels of moisture, will often require the use of double-wall corrugated. The double-wall board, such as BC flute, will provide more rigidity over the sidewalls of the package and will be less susceptible to bowing. Of course, single-wall designs are used in produce packaging as well, but it is important to consider the weight of the product and the supply chain when determining what paper to use. The final design consideration to make when creating produce packaging is the use of virgin fibers. Because of the demands of the product and the supply chain, virgin fibers are common throughout agricultural packaging. Virgin fibers will have less of a tendency to absorb moisture, which will help keep the structural integrity of the carton. However, one of the ways to increase the moisture resistance of recycled board is by adding a coating. There are several coatings in the market today that are used for food and beverage packaging. The coatings allow a recycled paper to have a higher resistance to moisture and humidity. Now that we have gone through common design elements of agricultural packaging, we will now discuss a few ways we can make improvements to design. When designing packaging, there are many performance metrics to consider. The examples we will show now highlight how small changes can make significant improvements to your packaging's performance. Something to keep in mind is that these improvements to performance are not always limited to stacking strength. Sometimes the improvements we make are to increase the stability of an individual carton or to facilitate more airflow to the product. We have two similar trays here in front of me. The first design has sharp corners, all 90 degrees, on all four sides. These sharp corners are going to be weak points in the design, and replacing them with radiuses will make for a more rigid box. The second tray, we've replaced the 90-degree corners with radiuses, and you'll be able to see in our compression test shortly that this increases the stacking strength of the box. We have a short video clip that shows a test being performed on these exact trays. Unlike the box compression test or BCT machine, this is not an official test procedure. It is simply a demonstration that gives you a visual of the difference in performance between these two trays. So we start by placing the first tray in the machine. You can see I'm going to load the tray with the 90-degree corners. So if we take the tray out and look at it, you'll notice that the failure occurred on the corners where the columns meet the sidewalls. Next, what we're going to do is take the second tray, which has the radiuses on the corners, the improved tray, and we're going to perform the same test. You'll see we loaded in the machine the same way as the first one, and now I'll stand on the platform and you'll see that this tray does survive the test. So again, remember, this is not an official BCT test, but it is a demonstration that shows the improvement in performance that is achieved by a small change in design. Now we can put this demonstration into numbers and show the results of the compression tester. The initial design reached an average of 1,716 newtons of force. That's 385 pounds. While the redesigned box reached an average of 2,563 newtons of force, or 578 pounds. You can see from the results here that put into numbers, the second tray performs 49% higher in compression strength, despite the fact that we did not need to affect the blank size to achieve these results. The next improvement we can make is creating a slight angle to the end panels of the tray. The first example I have here is a standard watermelon tray. Its sidewalls are vertical, like most types of packaging. The second example we have is a tray with angled sidewalls. This innovative design was created with the needs of a specific customer in mind. Watermelons are very large and heavy, and therefore have a tendency to put a lot of pressure on the sidewalls of the packaging. By angling these sidewalls only 2 degrees, we have created a stronger design that is more resistant to the pressure being put on the trays. This tray has the same footprint and blank size as the original and holds the same amount of product. This tray also still features the stacking tabs, and the slight pyramid shape creates a very stable design. This is an example of a change that was made to increase the holding power of the tray rather than the stacking strength. A similar approach has been used for shorter trays as well. This design features angled sidewalls on all 4 of the sides, on the length and width panels. Unlike the example with the watermelon tray, however, the purpose of this design was to create more airflow throughout the pallet. If you can imagine a pallet fully stacked with these trays, the trays on the inner column at the bottom of the stack will have trouble receiving airflow. The product will be shielded from the air flowing around the outside of the pallet, and the air in the center will become stale. Limited airflow to certain produce may result in premature mold forming as a result of moisture buildup. The angled sidewalls on this tray allow for small gaps of air to flow through. Because of these small gaps, air is allowed to flow evenly throughout the pallet, and the product on the inner column now receives sufficient airflow during transportation. This is an example of a design that was not inspired by stacking performance, but rather the specific needs of the product being packaged. Our final example of a design improvement that can make big changes in performance is one that does focus on stacking stability, or stacking strength. As we've discussed, the sheer weight of many types of produce require high levels of stacking strength. These 2 trays here have similar designs, but one features rollovers on the sidewalls. By adding an extra layer of corrugated to the sidewalls, we can greatly increase the stacking strength of the tray. You can see from the compression test results that the tray with the rollover on the end panels has much higher stacking strength than the original design. The standard rollover tray peaked at just over 2,500 newtons, which is about 560 pounds of force. Compare that to the improved tray, which reached a peak force of just about 5,000 newtons, or 1,125 pounds of force. Changes in design can have massive impacts on the performance of a box, and the compression test is a very useful test in showing how different styles of boxes will perform. Now that we've covered the purposes of agricultural packaging, common designs, and how to make improvements to designs, it is time to focus on the environmental impact of our packaging. To do this, we'll focus on wax-coated paper and how it compares to Smurfit Kappa's water-based coating. A common coating used in the packaging industry is wax-based coating. This coating is applied to the liners as a barrier against moisture. For this reason, it is a popular choice for produce packaging. Although wax-coated board is known for its resistance to moisture, the main downside is that it is not recyclable. Once a board is coated in wax, it cannot be recycled and needs to be thrown away after its use. Therefore, it is not a sustainable solution. To counteract that, we employ a water-based coating that is currently in use in the agriculture market. It is popular in food and beverage packaging. The tray we have in front of me is coated in that material. So we can take some water and pour it in this tray without fear that it will leak. This solution has the same performance characteristics as wax-based coatings, but the solution is recyclable. Because the coating allows consumers to recycle their agricultural packaging, we eliminate the main drawback of wax-based paper. With paper being one of the easier materials to recycle, it is important for us to eliminate as much waste as possible. Replacing wax-based coating with a water-based coating is a great way to reduce packaging waste. The world of agricultural packaging is a complex industry. There are many things to consider when designing trays and boxes that will hold produce. As we have discussed here today, there are common design elements that are used throughout the industry. Many of these features have become commonplace due to the years of testing and fine-tuning. We also went over some changes that can be made to result in significant improvements in performance. Finally, we touched on the environmental benefit associated with a water-based coated board. Smurfit Kappa has decades of global experience in the agriculture market, and we continue to develop new and innovative solutions to make improvements to our customers and the planet. Our global network of designers, subject matter experts, and experience centers allow us to share the knowledge we have gained over these many years to create the most sustainable packaging solutions for every market we enter. To see where Smurfit Kappa can take you in the future, or for any questions about this presentation, please visit our website at smurfitkappa.com, or you can reach me specifically at bradley.jones@smurfitkappa.com. Thank you very much for your time.